My name is Jifeng Pen. I'm an associate professor of mechanical engineering at the University of Alaska. I'm really excited to work on a couple of ADAC projects because, first of all, the work we are doing at ADAC not only contribute to the scientific and academic community's understanding of the Arctic, which is a very important topic right now, and also it provides new information to the many government agencies and local communities so they can use the information to make good decisions. With the warm-up of the Arctic Ocean, there are more and more shipping activities in the area. One potential hazard to the shipping activity is the presence of the ice. So what we are trying to do here at ADAC is to establish an index code that we can use to simply describe the hazard of the ice posed to the ship. Then that's a ship captain, when he knows the ice index for his planned shipping route, then he can feel confident to know that whether his ship can sail through this ice or not.
So we spent the last 3 years working on IceCon for the Great Lakes, which was a great success. And during the final phase of development for Great Lakes IceCon, it was identified that maybe we would like to use something similar to this in the Arctic. One of the things we've seen in the past few years in the Beaufort, Bering, and Chukchi Seas has been an uptick in vessel traffic. And not only is that vessel traffic that is done for research, but it also has to do with cargo, tourists that are coming into the area. But we're also trying to protect our coastal communities, really ensuring that people stay safe as they transit the area. With regards to IceCon, they had to figure out ice thickness, ice type, ice concentration, surface temperature, wind speeds, and all of that fed into a single number. The thing that varies within IceCon is the ship's ability. In ARCTICE, those things are switched in that we are taking in the same environmental factors, but we're producing numerous IceCon numerals. ARCTICE produces 7 different categories of a numeral based on different categories of polar classifications. The independent variable is the ship's ability to move through the ice. They know what that is, that doesn't change. The number that we give you, the dependent variable in this project, is our risk index. That's what changes depending on the vessel. The skeletal framework for ARCTICE was based off of the Polar Code, and in particular, the Polaris Amendment to the code. And the Polaris Amendment sets forth that particular framework, the risk index number, and that number is related to your ship's abilities. But what that does is it allows each vessel to take their own knowledge and awareness of what their ice abilities are and to pull a chart with that specific ability in mind and then determine how risky it is to move through. And then each of those charts is dependent on all the other environmental factors going on. Each chart is weighted differently for the ice classification of the ship. Let's say you understand your particular ice capabilities. What you'll do is you'll go and pull the chart for your ice classification for your vessel. And on that chart, it will show you in different areas increasing from positive numbers, which say the risk is low, to 0 to increasingly negative numbers. As those numbers get more negative, the risk increases. So you as a vessel want to pick areas of a chart that show positive numbers to 0. Those are the less risky areas. Any area that has negative numbers for your specific ice type or ice classification, those are the areas you want to avoid. For example, let's say that your vessel has a polar certificate that you've obtained, and your polar ship category is category B. Within that category, you know that your ice class is a PC7. So you are capable, but you're not an icebreaker. On the chart that you would pull from ARCTICE, you would pull the specific diagram for a PC7 vessel, which has been tailored and weighted to the strengths and abilities of your vessel. On the chart, you will see colors ranging from green to red. Green indicates positive risk values, telling us that you will be able to navigate this in all likelihood with a lower relative risk. As that color changes on the chart from area to area, depending on ice concentration, ice thickness, what the surface temperature happens to be, which affects characteristics, those colors change from green to red. So you, as a vessel captain or a route planner, you're going to plan a route for your vessel that goes through the green areas, maybe a yellow area, but you want to avoid the red areas on the chart. There are a couple scenarios that we imagine ARCTICE will be used for. First is pre-planning a voyage through the Arctic. So whether you are a cruise line that is looking at taking passengers up over the Arctic Circle, and you want to know 6 to 8 months in advance, what will the ice look like? You know, which route historically has been open versus which route has not been. So we expect that industry will use it from a hindcast perspective to take a look at where they predict they'll be most safe. We also expect people who are transiting through the region then to also pull the charts for that day, that week, so that they better understand on the local front, am I headed in the right direction? Do I need to have increased concern about the route that I had planned? And then they can make adjustments on a 12 and 24-hour basis, depending on what the charts show. So really, we imagine that charts will be used twofold, both for pre-planning a transit through the Arctic and during their transit through the Arctic. It's a very easy way for us to communicate to the mariner where relative risk is higher and lower, but you as the crew member on the vessel have to really be aware of what's going on outside. We still depend on you to say, I don't know about your chart. We're gonna go this way. All we're trying to do is make it easy and straightforward for you to more safely plan your route through the Arctic. The progress report for ARCTICE is that we're doing really well with our initial year mileposts. We had 6 things that we wanted to do. Really, we wanted to investigate which environmental parameters needed to come into the model. We wanted to look at suitable access. How will vessels bring this information in, depending on whether they're near shore or offshore? We wanted to investigate models from other countries. The Canadians and the Scandinavians have great models. And then we wanted to combine all of that together, develop the algorithm, and start doing some initial comparisons to some of the other data sources that we have. And I'm happy to say that we have accomplished everything up to date. We have one more milestone that we need to accomplish by the end of the year, and we are on track to do that one. And that really is taking the charts that we have generated and comparing them to some accident data that we have access to, some other charts from other sources, and really determining how well what we've produced fits with what we're seeing.